Hey, let's do this, guys. Okay. I was going to just start where it said the review, but actually these are two pretty good questions. So let's start up here, shall we? All right, lots of cool stuff going on. Let's see. Y equals, that represents the position of a y-axis at time t greater than 0. V is the velocity, A is the acceleration. Without a calculator, find. Okay, so first of all, let me go ahead and do my equations here. So this is the position equation. This is the velocity equation. So that's going to be 3t squared plus 3, because that'll be positive 3, t to the negative 4. And then the acceleration equation would be 6t minus 12t to the negative 5. Okay? And we're just evaluating all these at time 2. So without a calculator, here we go. This would be 2 to the third minus 2 to the negative third. Remember, on a free response, I can leave it like that. I could also say 8 minus 1 over 2 to the third is 8. And, I mean, we can figure that out, but I'm not going to. The velocity at 2 would be 3 times 2 squared and 3 and 2 negative fourth. Okay, 2 squared is 4 times 3, that's 12. Plus 3 over 2 to the fourth is 16. And again, we can do stuff with that. And then the acceleration at 2 is going to be 6 times 2 minus 12, 2 to the negative 5. So it's going to be 12 minus 12 over 32, which I'm sure reduces, but whatever. Okay? This one doesn't have units, but if it did, it would be like feet per second squared, something like that. Okay? Okay, use your calculator to find. Now, I like this, all right, because we have some inverses here. G and G inverse. So, remember to just follow the pattern. G inverse prime of 2 is 1 over G prime of something, okay? And we got to find this, like, magical point, right? That's what I call it, or this inverse point, or whatever. And so, off to the side, here's what I want you guys to write. G inverse of that, not prime, but regular, G inverse of 2 is something. So, G of something is 2, all right? I don't have any information about G inverse. I don't know what that is. But G of something is 2. That means there's something that's going to make that 2. Okay? I have a feeling this is not a guess and check one, which is why I said to use a calculator. So let's go ahead and do that. Let me pull up my calculator real quick here. Okay, so in my y equals, I'm going to go ahead and put my equation, which is the square root of x to the third plus 2x plus 5, okay? And I'm actually going to put in y2, I'm just going to put the line 2, because again, that's how I know that these are going to be equal. I want to know where that equals 2 to get this like point right here, okay? Let's go ahead and graph this. Ooh, fun. And I can probably do this by calculating an intersect point, I'm thinking. Okay, and I just go first curve, second curve, guess. And there's my intersection. So it's negative, so let's go ahead and write this down for my point. Negative 0.453. Negative 0.453. Okay, now, let me show you guys something cool real quick. Once I do that intersection, if I don't do anything else on my calculator, right now, that automatically stores that number in x until I go do something else. So I might use x instead because then it'll be more accurate, you know? Anyway, so that was this little point that worked, right? So g prime of 2 is 1 over, and then it's the derivative of g at negative 0.453. Okay? So now, if I go back over here, I could do this from the graph, I suppose. I could do calculate the derivative of this function at, I don't think it'll let me put x, will it? X equals x, let's see. Oh, it did. No, it didn't. That's not the right x, that's not what it was. It was 0.453. That's okay. All right, so I could go calculate the derivative of g at, it was negative 0.453. Okay, and the derivative is right up here. So remember, though, that this is 1 over that, you know? So I guess I could go 1 over, and then that number that I just got. Anyway, that's how I could do all this with a calculator. 1.519. You know, I had to approximate it and stuff a little bit, but as long as you guys get the idea, we'll look at some more inverse questions too, okay? Okay, sweet. Let's take a look at a couple of these questions here. Find the derivatives without using a calculator. This is a very big majority of the test is going to be this stuff right here. Let me actually grab this paper. 1 second. So I can give myself some more room, okay? All right, let's take a derivative here. Think of the square root as to the 1/2 power, right? So it's 1/2 to the negative 1/2, okay, times the derivative of the inside. The derivative, so that's my chain rule right here, and the derivative of the inside is 2x minus 1. All right? We're probably not necessarily going to simplify these. The only thing I can think of anyways is that would move down to the bottom, but that's good. Let's see here. Cool. This is a product rule with a chain rule in it. So it's derivative of the first times the second plus first times derivative of the second. Now, when I do derivative of the second, this is the chain rule, okay? It's 3x minus 1 squared times the derivative of the inside, which is 1. All right? Let me just clean this up a little bit. So I'm just going to go ahead and write 3x x minus 1 squared. Okay, you guys, for this problem, I can go ahead and do a big old chain rule and go like 1 over all this stuff times the derivative of the inside, which is a product rule with a chain rule, okay? And I could go ahead and do that. But there's actually an easier way. So anytime I see an ln problem, I kind of just ask myself, is there a way to use log or ln properties to make this a little bit easier? Okay, so we're going to go like this. First of all, this is multiplied, so I could split this up to ln x squared plus ln cube root x plus 1. All right. And then they actually both have exponents, a 2 and a 1/3. I actually can bring those down front. So this is 2 ln x, and I can bring that down front, and that's 1/3 ln x plus 1. And then this is so much easier to take the derivative of. Now look, this is still y. Okay, I haven't actually taken a derivative yet. At this point, it goes like this, 2. And then derivative of ln of x is 1 over x. And then 1/3. Derivative of ln x plus 1 is 1 over x plus 1 with a little tiny chain rule right here, but that's just a 1. Okay, clean this up a little bit. So it's 2 over x plus 1 over 3x plus 1. Way easier than trying to do like product rule, chain rule, and all that stuff. So log properties at the beginning is really helpful with certain questions. Okay. All right, guys, here we go. We got a product rule. Derivative of the first times the second, and then first derivative of the second. Now, the problem is the derivative of the second is a little tiny chain rule. We got to multiply by -1, okay? So be careful of that because you have a negative t in the exponent. So, you know, I might write this as 3t squared e negative t minus t to the third e negative t. Just move that up or something. Okay? Okay, cool. Let's see here. For log base 6 x squared plus 1 to the 6th to the 3rd. Okay. All right, you guys. This, whenever you have a number out in front, that is going to stay out in front. Okay? And then I just do my regular chain rule. I'm going to start outside and go in. I guess, though, since I'm bringing the 3 down, I might as well multiply those. So it's going to be 12 and all that squared. That's like the first part of my chain rule. Just realizing that this is going to be a very long chain rule, so I need to move this over. Okay. And then all this stays the same. Log base 6 of x squared plus 1. Okay, so basically I did that, so that's gone. So next I have log base 6. All right, I'll give you the formula for that, I think. That's a bit of a tricky one. Let's see if I can find where it was on here, show you guys. Oh shoot, it was in, it was over here. There we go. So log base anything, the derivative is 1 over x ln a. So you just do, you divide by ln of the base. Okay, so I'm still doing chain rule. So it's 1 over that. And then because it's log 6 instead of ln, I just put a ln 6 on the bottom. And then, so that's like that part. And then I have to put this in there, x squared plus 1, 2x. All right. Okay, cool. And then that really doesn't simplify at all, so I'm just going to leave it like that. Looking crazy. Okay. Try to get these memorized as soon as you can. Like I said, this test came up on us pretty quick, so I'll go ahead and have the formulas for you, but here we go. ln is 1 over. Okay? And then it's like, okay, boom, that one's done. Okay, arctan goes 1 over 1 plus blank squared. All right? And the thing that's inside here is 2x. And then the derivative of 2x is 2. Okay? And that's it for that one. Okay, I actually really like, let me move this, that they put these two questions together. This is cool. Because, do you guys see the difference between these? There we go. Okay, where it says ln of arctan of 2x up here. This one is the ln of arctan of 2x. There's only a single x. This one says ln of x, arctan of 2x. The difference is this is a chain rule because that's inside of the ln. This is a product rule. The little chain rule in it, but it's a product rule. Okay, because there's two separate x's. That's the biggest thing I look for. So it's derivative of the first, second, plus the first times derivative of the second. Okay, again, tan is 1 over 1 plus something squared. And the something is 2x times 2. If this were on multiple choice, I mean, there's a chance they would square that out, make that 4x squared. But, all right, but that's it. Okay, so the difference in chain rule and a product rule, make sure you feel pretty good about that. Oh, this is fun. ln arcsine, I'm going to put an extra parenthesis here just for clarity, to the third. Ooh, look at that. That is a 4-part chain rule. I think that's the first one with 4 that we have. Starting out, moving in to the third, and then ln, and then arcsine, and then x squared. Okay? Oh, this would be so fun. All right, bring the 3 down in front. All of that inside stays the same. So anything to the third is 3, and then that squared. ln arcsine x squared. It takes care of that. Okay, arc sine, the derivative is 1, let's see if I remember this one, square root of 1 minus x squared. I'm reasonably sure. Did I keep that paper up? I was showing you guys. Let's see here. No, I did not. Okay. I'm like 95% sure that that's it, but let me just not make any mistakes because that would be embarrassing. Okay. So derivative inverse, where's derivative inverse? Trig. Aha. Okay. Boom. Boom. Okay, there we go. So 1 over square root of 1 minus x squared. And then cosine is just negative. Same thing. Tangent is the one that's a little different. All right, cool, cool. Okay. And so this will be like x squared squared. So that does the arc sine. And then the derivative of x squared is times 2x. Okay, just big, huge, long chain rule. So fun. Okay. Oh no, arc sine, not arctan, arc sine of t. Okay, this is weird because it's using weird variables. It's using like x. We can put x prime, or we can put like dx dt because I'm going to take it with relation to t. Anyway, all right, derivative of cosine is negative sine, okay, times the derivative of the inside, which is 1 over the square root of 1 minus t squared. Okay? Now, do they want us to simplify sine and arc sine? I mean, I would be careful of that because that only works between certain parts of the quadrants. So if I don't have to simplify, I'm not going to simplify that. All right? I'm going to leave it just like that. Okay. And then arc tan v minus 1 squared. All right, so my derivative is 1 over 1 plus blank squared. Yeah, I think it means, I'm just like checking, but I think it means the arctan of that. Because if the arctan was squared, it would be there. Okay, so anyway, so then in here, I put the v minus 1 squared, right? Then times the derivative of the inside. So now I got to do times the derivative of this, which is going to be 2v minus 1 to the first, and then the derivative of the inside, which is just 1. Okay? You could change that to the fourth. If it was multiple choice, it would probably do that. All right, very cool. On to some fun ones. Okay, so that was just a bunch of just taking of derivatives. Okay, things that you're going, well, yeah, let's go and do this. Equation for the tangent line. Actually, this is minus 3. Whenever you guys see the words equation of the tangent line, you're immediately going to write y minus y1, mx minus x1, and our whole goal is to fill in that, and that. Once we do that, we're done with the problem. Okay? I don't know what y1 is yet. I don't know what m is. I know x1 is 0. Okay, the way I find the y value is I plug this in to find the y value. Anything to the 0 is 1. 1 minus 3 is negative 2. Okay? So minus negative 2, I mean, you can leave it. You can put plus 2 if you want, whatever. All right, now, m represents the derivative. So let's go back to here. Let's take the derivative of this. The derivative of e to the negative x is e to the negative x times negative 1. And then the derivative of 3 is 0. I had to do that times negative 1 because of chain rule. So it's e to the 0 times negative 1, which just gives me negative 1. And that's the equation of a tangent line. And again, just leave it like that unless, you know, of course, like I said, if it's a multiple choice question, it's not in point slope form. They might have you do like distribute that, subtract the 2 over. Okay, but don't do that unless you have to. All right? Because that's just more places to make mistakes. Cool. You're definitely going to need to know how to do implicit differentiation. This is where the x's and y's are messed up. Or mixed up, I should say. Not messed up, mixed up. It goes like this. The derivative of x squared is 2x. This is a product rule. I'm going to let negative x be the first product and y be the second product. So it's derivative of the first, second, first derivative of the second. And then the derivative of y squared is 2y dy dx. And the derivative of 5 is 0. Then what I do, guys, is anything with a dy dx will stay on the same side. Anything without a dy dx goes to the other side. When I move this over, I minus the 2x over. I add the y over, okay? So it becomes minus 2x plus y. All right, now I need to factor out a dy dx. And then I divide this over. All the way over negative x plus 2y. And that is my answer for dy dx. Okay? Okay. Here we go. Another equation of a tangent line question, but this one including implicit differentiation. Okay. Okay, here we go. Derivative of the first, or no, sorry, I made that sound like product rule. Derivative of x squared is 2x. Derivative of 2y is 2 dy dx. Derivative of y squared is 2y dy dx, 0. Okay, now you guys, I'm given these points. This is an x and a y. You can actually plug them in right now, or you can solve for dy dx like we did on this last one and then plug them in. So it's completely up to you which way you want to do it. I think I'll solve for dy dx and then plug them in. So I would subtract the 2x to the other side. Okay, so I'm subtracting that over. I'm factoring out a dy dx. I'm going to do that in the same step if y'all don't mind. And then I'm dividing this over. Okay, so here's what I get. Dy dx is negative 2, and then x is 1. And then 2 plus 2 times negative 2. So it's negative 2 over 2 minus 4. So that equals 1. All right, so that's how I can find, oh, okay, I thought it was just asking me for a slope, but it said equation of a tangent line. I always go back and reread at the end. It's a good thing to do like when practicing for the AP test. Y minus y1 equals mx minus x1. Okay, just to make sure I got that right. That m was my slope there. Okay, here's a trig looking one. All right, here we go. Y prime is 1/2, all of that to the negative 1/2, okay? Times derivative of a cosine, which is negative sine, times derivative of x, which is 1. Okay, big, huge, long chain rule. So I did the square root, then I did the cosine, and then I did the derivative of the inside. All right, when x is pi over 4, well, first of all, actually, because this is a y minus y1 equals mx minus x1, okay, x is pi over 4. When I plug that into the original, I get the square root of cosine, pi over 4 minus pi over 4, which is 0, and the cosine of 0 is 1. And then here, okay, here's what I get. I get 1/2 cosine of pi over 4 minus pi over 4. So cosine 0 to the negative 1/2. And then negative sine 0 times 1. Okay, cosine of 0 is 1. So that basically just puts the square root of 1 on the bottom. Sine 0 is 0. These are smashing each other up. Okay. Anyway, and if I multiply anything by 0, I just get 0. So that's my equation of tangent line. All right, just looking to find all the different parts. Okay, 15 is super fun. Let me pause this while I write this table down. All right, you guys, number 15, this is like a really good review question, okay? Because it's going to make sure that you know how to do product rule, quotient rule, and chain rule. A couple different ways, right? Okay, so let's start with it's just product rule. It wants me to find the derivative of f of x times g of x. So it's going to be derivative of the first times the second plus first times derivative of the second. And at 1, so let me just put all of these at 1. Okay. F prime of 1, that's 5. Regular g of 1 is 1. Regular f of 1 is 2. And g prime of 1 is 3. So 5 plus 6 is 11. Okay. Next one is a quotient rule, f of x divided by g of x. So it's quotient rule goes derivative of the top times the bottom minus top times derivative of the bottom over the bottom squared. And so again, this is at 1. So I'm not going to rewrite them all. F prime of 1 is 5. G of 1 is 1. And then it's a minus. F of 1 is 2, g prime is 3, over g of x squared. Okay, so I end up getting 5 minus 6 over 1. So I got negative 1 for that. Let's see. C is a chain rule. Now, I'm going to write the question down here so that you guys can see it. When I take the derivative of that, I go derivative of the outside, leave the inside the same. Derivative of the inside. And because it's having me evaluated at 1, okay, so these are the first things I'm going to find. G of 1 and g prime of 1. Okay, g of 1 is 1. G prime of 1 is 3. And then I need to take this and do, well, what's f prime of 1? F prime of 1 is 5. All right. Now this one goes the other way for part D. It wants g of f of x. Okay, so first I'm going to write this out. Derivative of the outside, leave the inside the same, times derivative of the inside. Okay. Now again, I'm calculating this at 1. So this time I need to find f of 1, f prime of 1. Okay, f of 1 is 2, f prime of 1 is 5. And now I'm going to go ahead and take that and find g prime of 2, which was 7. Okay, I got 35 for that one. All right, so really good review of product rule, quotient rule, and chain rule. Okay, there will be, like, with every test, it's going to keep covering from the beginning. So limits, derivatives, like, we're just going to keep covering that. That's a good thing. That means it's not going to fall out of your brains, okay? So limit as x approaches infinity of... Okay, if I were to multiply this out, so like I'm not going to, right, because that would be a pain. But if I were, 2x squared is 4x squared times x. So that gives me 4x to the third and a bunch of other stuff. And then on the bottom, x to the third and a bunch of other stuff. Since I'm going to infinity, we compare the degree of the top and bottom. Since it's the same, I'm going to use coefficients. That limit is 4. Oh, I was like, that's the same question. Not exactly. Okay, if I were to multiply this one out, I would just get 2x squared on the top, x the third on the bottom. And the rule for that is if the bottom degree is bigger than the top, it always goes to 0. Yeah, okay. All right, you guys remember that with numerical limits, the first thing we want to do is just plug it in and see if it works. So I need to figure out what's arctan of 1. Oh, whoops, on the bottom that was supposed to say x plus 1. And then 1 plus 1. Okay? All right, I think we talked about this in class. The only one, I mean, not like the only one, but kind of, that I've seen you have to evaluate is like arctan of 1. Let's talk about what that means, okay? So just off on the side here. What does arctan of 1 mean? Okay, well, it means where does tangent of something equal 1? And if I go and I look at my chart, where does tangent equal 1? Pi over 4. And this one's being pretty easy with us because it's not like making me worry about quadrants and stuff with the arctan stuff. So basically, the tan of pi over 4 is 1. So arctan of 1 is pi over 4. And then 1 plus 1 is 2. Oh, free response test. Boom. Leave it like that. Do not try to simplify it, guys. Free response test, leave it. Multiple choice test, I would go, okay, that's 2 pi over 4, which is pi over 2. And then I'd be like, well, pi over 2. So if I multiply by the reciprocal, the final answer is pi over 4. But I might have simplified that wrong. So I'm not going to take it past this point unless, you know, it's multiple choice. All right. Whew. Ooh, we chilling. Okay, here we go. We are moving right along. 19. For 4 cos x sine y minus square root 6 equals 0, find dy dx at the point pi over 6, pi over 4. I think it's saying when x is pi over 6 and y is pi over 4. Okay. Find the derivative at that point. All right, cool. I'm going to do a product rule. I think I'm actually just going to leave the 4 out to not confuse me. And then I'll just do my products right here. Okay, the derivative of the first. Derivative of cosine is negative sine times the second. And then the first, and then derivative of the second. That's going to be cosine y dy dx. Okay? I didn't have to do that on derivative of the first because this was like dx dx. So I don't really need that. That's dy dx. So I do. The derivative of a constant is 0. Okay? I'm going to go ahead and plug all this stuff in right now because I think that sounds so fun. All right. Actually, let me do it like this. This is the x coordinate. Okay? Yeah, we'll do that. The sine of pi over 6, if I go look at my chart, sine of pi over 6 is 1/2. Okay? The cosine was root 3 over 2. All right. Next, pi over 4. The sine of pi over 4 is root 2 over 2. The cosine of pi over 4 is also root 2 over 2. So, this is very strange. Okay, I get 4 times negative root 2 over 4 plus root 6 over 4. Root 2 over 4. Dy dx is 0. Oh my goodness, I wasn't really going to distribute this 4, but look, I think I shall because look, it crosses everything out. So negative root 2 plus root 6 dy dx is 0. Add that over. root 6 dy dx is root 2. Dy dx is square root 2 over square root 6, which would be an acceptable answer, or 1 over root 3, or any number of things that are equivalent to that. Okay? Whew, not bad. All right, inverse question. Inverse question. Make sure you guys look for these. We like the inverse questions. 2, 1 is a point on the graph of f. You know what that makes me want to write? F of 2 is -1. F inverse of -1 is 2. That's my like magic point right there. Okay? That's what that tells me. Find f inverse prime of -1. Well, that's going to be 1 over f prime of, and f inverse of -1 equals what? F inverse of -1 equals 2. Okay? Now, it gave me an equation for f. So that's going to give me 3x squared plus 1. When I plug in 2, it's 3 times 2 squared plus 1. 3 times 4 is 12, plus 1 is 13. So don't just say, oh, the answer is 13. Remember, it's 1 over 13. All right. Nice. Good inverse question. Okay, here's another inverse question. Find g inverse prime of 1. Okay. This one, I'm going to have to figure this out a little bit. It didn't give me a ton of information. So g inverse of 1 equals something, which means g of something equals 1. Which means I have to find out where that equals 1. Is this a calculator question? It has to be a calculator question, I would think. Okay, let's see here. G inverse prime of 1 is going to be 1 over g prime of something. So what equals, so that has to equal 1. Oh, I got it. I was like, can we do that without, yeah, you actually can. What if x equals 0? I get e to the 0 plus 3 times 0. So I get 1 plus 0, which is 1. So 1, 0, 0, 1. That's my magic point. If it's expecting you to do it without a calculator, it means it's probably a fairly relatively simple answer that you can kind of just think through. Okay, so 1, 0. So the derivative at 0, so let's take this, g prime. The derivative of e to the x is e to the x. The derivative of 3x is 3. Evaluate that at 0. I get 1 plus 3, which is 4. So my answer is 1 over 4. Very, very good example of a... I lost my words for a minute. Good example of a inverse function. Okay? All right. We haven't looked at a ton of related rates. I think now when we go back to it, you guys, you're going to be like, oh man, related rates are so easy. Okay. A point moves along a curve so that the y-coordinate is increasing at a rate of. That means dy dt is 4. Find the rate of change of the x-coordinate. What is dx dt with respect to time when y equals 2 centimeters? Okay. We're taking the derivative of this with respect to time. So this is 1 dy dt. And then this, remember this is like 1/2. So it's 1/2 x to the -1/2 dx dt. Now, dx dt is what I'm looking for. Okay? dy dt is 4. But how do I know what x is? Well, I got to find that. And I can actually do that by saying, oh, if y is 2, what's x? So let me come over here. If y is 2, square both sides, x equals 4. All right? And now I have to solve this. Okay. 4 equals 1/2. Okay. You guys, negative puts it on the bottom. And 1/2 is square root, so it's a square root of 4 on the bottom. And I'm just going to go like this and say that the square root of 4 is 2. So 4 is 1/4 times dx dt. And then I'm just going to go ahead and multiply by 4 on both sides to solve that. And so I get dx dt is 16. Want to make sure that I include units on that, though. And I'm just going to look at the units for y. Centimeters per second, so that's going to be centimeters per second. Okay? Pretty straightforward, the related rates, I think. Okay, a block of ice is exposed to heat in such a way that the block maintains a similar shape as it melts. It's initially 2 feet by 2 feet by 3 feet. So it's a 2 by 2 by 3 foot cube or whatever. Okay? The rate of change of the width, all right, dw dt, yeah, let's go and go wide, high, length, okay, is negative 1/3 feet per hour. Find the rate of change in the volume when the width is 1. Okay, the volume of this thing is length times width times height. This does not want me to do a 3-part product rule. Let's think for a minute. Okay, got it. Because of the ratio here though, and it stays in the same ratio, you guys, if 2 to 2 to 3 is a ratio, if that one's W, that one's also W, like H is the same as W. And then L, well, let's see, if L is to 3 as W is to 2, so 2L equals 3W, so L is 3 over 2W. So that is 3 over 2W, okay? And so instead of saying my volume is L times W times H, it's actually W times 3 over 2W. And so another way of writing my volume, all in terms of W, is 3 over 2W cubed. That's a little tricky. All right, so dV dt is, bring that down in front, 9 over 2 W squared dW dt. It wants me to find the rate of change of the volume when W is 1 and dW dt is negative 1/3. I'm simplifying, but remember we talked about don't even simplify. Negative 3 over 2, and then it's feet cubed per hour. This is a tricky one. I think this is a little bit hard. Just setting that up, that's a little harder than anything I feel like I would give you right now. Okay. Part B, the amount of time it would take for it to completely melt. Well, let me think about this here. 2 times 2 times 3 is, it's a 12-foot cubed block. And if I'm losing 3 over 2 feet cubed per hour times time, and I want that to go to 0, okay, if I get rid of the units. When does 12 equal 3 over 2t? Probably at 8. It would take 8 hours at that rate to melt all the way. Oh, interesting question. Little too difficult for what we're doing right now, but hopefully that all made sense to you. Cool. All right, let's do these last few questions really quick. 24 says find f inverse prime of 5 if f of x is, and it's on the interval from 3 to infinity. Okay, well, f inverse prime of 5 is 1 over f prime of something. And what this is telling me is that the f inverse of 5 equals blank, f of blank equals 5. So I need to know where that equals 5. Again, I feel like we did this problem. I really can't imagine them making you do that without a calculator. Let's see, so maybe it's like 2 or something. I don't know. I think we did this. Let me pause it and go get the answer. Okay, yeah, we did do this question, I remember now. So it crosses at 4, 5, which means f inverse of 5 is 4, which means f of 4 is 5. So this is 1 over f prime of 4. I can do that on my calculator, or I can pretty easily just take the derivative of this. And then at 4 is going to be 3 times 4 squared minus 8 times 4 plus 3. So it's going to be 16 times 3 is going to be 48 minus 32 plus 3. It's going to be 16 plus 3. That's going to be 19. But the answer is going to be 1 over 19. I'll box that. Cool. All right, let's do a couple more. Y is e to the x squared minus 1. If I want to take a double derivative of this, my first derivative is e to the x squared minus 1 times 2x. Okay? My second derivative, I now have to go to a product rule, right? So it's derivative of the first times the second. This is derivative of the first, because I had to do a chain rule, times the second. And then the first times derivative of the second, which is just 2. And then you can combine like stuff if you needed to. Okay, the derivative of this. All right, I can't use ln rules to separate this, sadly. It would have to be that over x would have to be inside there to use ln rules, so I can't do that. So I'm just going to have to hardcore quotient rule this bad boy. Derivative of the top, derivative of ln is 1 over x squared minus 1 times 2x, times the bottom, minus the top, derivative of the bottom over bottom squared. Am I simplifying that? Heck no. Absolutely not. Okay, and then here's an implicit one we'll do real quick. All right. This is 3y squared dy dx minus 1. And then I have to do a product rule here. Derivative of the first times the second. First times derivative of the second. Okay? Now look, I got to get the dy dx's on the same side. So I'll go ahead and put 3y squared dy dx minus ln of x dy dx. And I got to put everything that's not a dy dx on this side. So I'll put y over x plus 1. I'll factor out a dy dx. And then I'll just divide by 3y squared minus ln x. And I am not planning on simplifying that. Okay? We did 28 already. Somewhere. So I don't want to really do that again. We also did 29 through 32, but I do want to do those again, actually. A constant to a constant. X to a constant to the x, and x to the x. Okay, you guys. So I'm going to just make up numbers here because I think it'll help you make more sense. What's the derivative of, let's say it was like y equals 2 to the 4th. What's the derivative of 2 to the 4th? Well, 2 to the 4th is 16, and the derivative of that is 0. The derivative of a constant to a constant is always 0. Okay? Because it's still a constant. All right. X to a constant. Let's think of an example for that. That would be like x to the 3rd. What's the derivative? 3x squared. So x to a constant is constant x to the constant minus 1. So we got that one. Okay. This next one here, a constant to the x. Let's do like 5 to the x. You guys remember that? The derivative of a constant to the x is 5 to the x ln 5. So this is going to be 5, well, not 5 because c. C to the x ln c. That's just the rule for that one. All right, guys, the last one, a variable to a variable. This is the kind of weird one we talked about where you do logarithmic differentiation, where basically I need to bring that down because I don't have a rule for a variable to a variable. So what I do is I take the ln of both sides. And then that x can move down in front. And I do at this point implicit differentiation, right? 1 over y dy dx. And then derivative of the first times the second, first times derivative of the second. Okay? So that simplifies to like ln of x, and then x over x cancels to just give me 1. So to solve for dy dx, I basically, though, just have to multiply y on the other side. Now, I've seen multiple choice problems where it just puts times y, like I've seen that. I've also seen problems where it's put times x to the x, because that's what y is. Okay, so that one's tricky, but hopefully you know all of the other rules. My last few minutes, you guys, I'm just going to show you a couple things that you need to know how to do. You need to know how to do derivatives on the calculator. It's like easy money. Like, it doesn't matter how, you know, crazy that is. Okay, let's like say it's like that. That's fine. It doesn't matter. All you have to do is go from the home screen. You can go math 8, because that's where derivative is. All right. Write in your equation. I think I made it crazy. So it was like ln of sine of x squared plus 1, parenthesis, parenthesis. And I'm evaluating that at 4. Dang it. How did I was like, I should probably check this to make sure this is actually a real answer. I don't know. What should I evaluate this at? It's because, okay, so let's evaluate it at 2. Let's pretend I made it at 2 instead. Jeez Louise. Dang it. That's what I get for making up questions, right? How about let's evaluate it at negative 0.5. Yay! Okay, I got one to work. All right. Sorry, I should have been more careful because ln and sine have weird restrictions and stuff. Anyways, you guys get the idea, okay? So you need to know how to do that. All right, cool. Let's see what else. So I changed that to something that actually worked. Okay. Okay. I don't know if you guys remember back to when we did this question. I put a star by it. That's pretty smart of me. Okay. It's a really good question. Okay, so let's take a look. Let me show you which one we're working on here. This is, it's in your packet, but you can just kind of watch. Do this right here. Okay, that's the one I'm looking at. This was in lesson assignment 3.5. Okay, let's just like focus on that real quick. All right, let f and g be inverse functions such that, blah, 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 blah. Okay, so here's how I would do this. I'd say, okay, g prime of negative 1 is 1 over f prime of something, right? Now, before I can figure out what the f prime of something is, I have to write like this. So g, so take off the prime. Use a smaller pencil. Okay, so g of negative 1 equals something means f of something equals negative 1. So I go look over here. F of something equals negative 1. None of those equal negative 1, so that's not possible. Okay? So for A, I'm just going to say not possible. So let's look at B. Okay, g prime of 0. All right, g prime of 0 is 1 over f prime of something, right? Off to the side, I'm going to write Okay, g of 0 is something. That means that f of something is 0. And if I go look, sure enough, right here, f of -1 is 0. So g of 0 is -1, which means I put a -1 right there. Now, do I know what the f prime of -1 is? I sure do. It's 2, so this goes to 1 over 2. Okay? If you want to like pause it and try these other two real quick, that's not a bad idea. I'll show you how to do these though. Okay, g prime of 1 would be 1 over f prime of something. And then I go, all right, g of 1 is blank, which means f of blank is 1. Sure enough, right here, f of 0 is 1. So that's 0. And f prime of 0 is 1/5. So this is 1 over 1/5, or just 5. Okay, g prime of 2 would be 1 over f prime of something. And I go, g of 2 is blank, so f of blank is 2, and that is not here. F, I don't have the information for that. So this one is not possible. All right. And then my last one, I made a lot of stuff here. Let's see if I can erase this. Okay. This is 1 over f prime of something. Now, my point is g of 3 is blank, so f of blank is 3, which is there. F of 1 is 3, so g of 3 is 1. So it's 1 over, and then f prime of 1 is 4/3, which you can leave it like that, or you could do 3/4. So you definitely should know how to do that before you test, okay? Okay, something else that you guys should know. A vertical tangent line means the derivative is undefined. A horizontal tangent line means the derivative is 0, because I've got undefined slopes and I've got 0 slopes, right? So typically what happens with these type of problems is you'll get some equation that's like, okay, dy dx equals, and then it's like boom over boom. All right, basically here's how it works. Bottom equal to 0, that gives you vertical tangent lines. Top equals to 0, that gives you horizontal tangent lines, because that's the slope of 0. Okay, so you got to know that. Or you guys, if it's just a regular equation and it's not a fraction, and it says where does it have horizontal tangent lines, it just means derivative equals 0. So just set it equal to 0 and solve it. Okay? Anytime on this test when it says points and it bolds it and underlines it, it means like if you got an answer of x equals 1, it doesn't want that. It wants a point like 1, 7 or whatever. So if it says points, that's what that's looking for. And other than that, like I think we covered everything okay. So if you get stuck with it till the end, hopefully you're good. Remember, we're taking this over 2 days. Calculator, no calculator. All right. You guys are awesome.